Okay, we're given a problem here, number 5. The largest swimming pool in the world, back then I guess, is located in Casablanca, is 480 meters long. Okay, so picture a big pool, a long pool, 480 meters long. Now, we're being told that there are two swimmers. Suppose that two swimmers at opposite ends of the pool. Again, visualization. I have a swimmer on one side of the pool and a swimmer on another side. So maybe I should draw this pool just to start. We know we have a pool, and let me see if I can get my drawing features here. I know I have them up here. Here we go. We've got a nice little box, and let's draw a pool. Okay, long pool, huh? All right, so we're told that there's a swimmer on each side. Are they given names? No, we don't have it. But let's read all the way through. It says here, suppose two swimmers at opposite ends of the pool jump in at the same time and begin swimming towards each other at speeds of 70 meters per minute and 80 meters per minute, respectively. We already learned that word respectively. If you didn't, understand that swimmer A, or the first swimmer, would be 70 meters per minute, and the second swimmer would be 80. Now they don't have names like we did in problem number 4, but we can now picture one being on one side, one being on the other. Now, what distance will each one swim in X minutes? Okay, so now we're given a variable in X minutes. And B, copy and complete the diagram below, which shows the point at which the swimmers will meet. Let X represent the time that each one has been swimming, which goes very much into problem number A, or letter A, where it says what distance each one will swim in minutes. Okay, so X is going to represent that time. And now we have C. Use the information in this diagram to write an equation. So we have this diagram here, and we have our pool. And then we're going to solve the equation to find how many minutes it will take the swimmers to meet, and then at the point in which they meet, how far will each swimmer have gone. So again, we've got a whole bunch of problems here, and it can seem overwhelming when you just, where do I begin? And they're just throwing all this information. Our brain really isn't capable of just picking this up. Now, there are probably some people who just do this all the time, or they could just be math teachers. And I tell you, for one, I don't do this all the time. But let's say there are people who really study math and they teach math, and their whole world is math, and they could probably just look at this and say, well, they picture it in their mind, and they're starting to do the math already. And you could certainly do that if you did enough math throughout the day and throughout the week and throughout your life. But we don't really, our minds are not set up in a sense to just grab this information and start running with it. If I were to read a story to you, or you were to read a book, or you were to watch a movie, your mind is able to take things in that form and put things into a certain order as they're given to you. And you're able to create a story. Your mind just really gravitates to that. With math, it's a little bit different. It's very hard for us to equate things. In fact, when you watch a mystery movie, or you're reading a book and you're trying to solve who did what, you're given clues throughout it, but you don't necessarily catch all those clues until you start getting more clues, and then by the time you have all these clues, you're able to make a clearer, let's say, a guess at who may have done what based on the information. And that's what math is. Thing is, it just throws it all at you at once, and it's very difficult to just process it. So we're going to now do that. This is the process of processing the information. Now, what we do know is that it's a 480 meter pool. So we can just put that over here. And we're going to say this is 480 meters, right? I'm going to just use M. And if I were to do this right, I'd need to sort of put a little line here. And you may see how we do these things. And there's just sort of like an arrow. And let's just say it sort of look like that, okay? And actually, this arrow probably ought to be a little closer to the 480, but it's just a way of us showing that this is 480 from end to end, okay? In fact, we didn't even need those little lines in the end, because we're assuming we're talking about the box here, the pool that we have. So it's 480, and I could have just done it in the inside and just put little arrows in there as well. But I wanted to leave that open so that we can see the swimmers. So, so now we know that there is, we're being asked, what distance will each one swim in X minutes? Well, distance, let's go back, put our distance is equal to rate times time, right? So distance is equal to rate times time. Now, what do we understand about each of these? First off, well, they're traveling at 70 meters per minute and 80 meters per minute. So what distance will each one swim? Well, we don't know, but we don't know the actual distance, but we know that if it's an X amount of minutes and we have their rate, we can say that, let's say swimmer number 1 and swimmer number 2 is traveling, the first one is traveling at 70, right? And the second one's traveling at 80 meters per minute, and they're going to each travel X amount of time. Now remember, we're just going to say go, okay? And they jump in the pool, and they're swimming, okay? So one's coming from this side, so swimmer number 1 is jumping into the pool, and then swimmer number 2 is jumping into the pool, and they're just going to swim, and they're swimming, okay, all right, and eventually they're going to meet somewhere, right? And I would venture to say that they're going to meet somewhere closer to the left side because that swimmer is not moving as fast. So they're going to swim, and they're going to eventually, they're both traveling, and then boom, they sort of run into each other, and hopefully they don't hit their heads and drown. But what we're trying to say here is that they're traveling for the same amount of time. The question is how far each one went. But I can certainly tell you that one is moving 70 meters per minute and the other one's moving 80. And they're both going to be traveling at the same amount of time because they're eventually going to stop from the minute that they run into each other, let's say. So we can say that the distance each one will swim is 70x and 80x based off the information. Now that's not a distance, right? Well, it isn't. But it is in algebra because it's giving me the rate and the time. The rate of 70, x time. Rate of 80, x time. So we've been able to determine that. Now let's go over here and just make our little equation over here. Because we're going to say that the distance, we had two distances that they're each traveling, right? And one's going to be 70x, and the other one's going to be 80x. Now, as I said before, the distances really are not going to be equal, are they? Because one's going faster than the other. So we're not going to be doing what we did in other problems. We say, well, d1 is equal to d2. It's not. Okay, because it's the time that is the same. But the distances are going to be different because they're traveling at different rates. Now, complete and copy the diagram below which shows the point at which the swimmers will meet. And we'll let x represent the time that each one has been swimming. So, how can we illustrate that? Well, let's take a look. We have 480 meters going across, and we would just plug in our information that we had from our very first. Here, this is 70x from our first problem, and this is 80x. Okay, we know that 70x is the distance that swimmer number 1, okay, is going to travel, and we know that 80x is the distance that swimmer number 2 is going to travel. So we're able to fill in that those question marks there, and we're going to move on now to C. Use the information in this diagram to write an equation. Well, what would the equation be? What's equal to what? Well, here's where the 480 comes back in. We know that this long distance from one end of the pool is 480, and we know that if we add swimmer 1, which is 70x, and swimmer 2, which is 80x, and we add them together, it's equal to 480. So we can say 70x, well, that's a big 70. Won't leave me room to solve the problem, would it? Let's put here 70x plus 80x is equal to... Actually, before we do that, I'm just going to take one step back, and just in case I'm confusing you. We know that they're both traveling distances. We know that distance number 1 plus distance number 2 is equal to 480 meters, right? And again, I already illustrated that above. This is the first distance, and this is the second distance. And if we add the two distances, they're going to be equal to 180. Now, what is D1? Well, it's 70x. And D2 is 80x. And that's going to be equal to 480. So we now have a formula, or an equation that that illustrates the relationship between the two swimmers and the distance that they're traveling. And this will allow us to now solve for x, and it gives us an opportunity to answer the other questions that we have here. It says solve the equation to find how many minutes it will take the swimmers to meet, because x is equal to the time, right? But if we know they're traveling a certain distance and we know a rate, we can figure out the time. Okay, so let's figure that out. Let's add these two, and we get 150x is equal to 480. Okay, now we're going to end up here with a fractional. We're going to say x, we're going to divide each side by 150, and we're going to get x is equal to 480 divided by 150, and if you do your math, you're going to get 3.2. If you do you can do it fractionally, but we're trying to get this down to a decimal, and it's 3.2 minutes. Okay, because we were told that this is in minutes. So x is actually going to be equal to 3.2 minutes. Now let's go back to what that means. Well, when each swimmer jumped into the pool, one pool, they were both traveling at a certain time, and the time that it took for them to run into each other, or to just say cross each other, would be exactly 3.2 minutes. Now 0.2 minutes is what? Let's put this in terms so we can get that 0.2 visualized. 0.2 minutes would be 1/5 of a minute, and 1/5 of a minute is 12 seconds. So it's really 3 minutes and 12 seconds. So if we were sitting there by the pool, we're sitting in the middle somewhere, and say, hi, I'm watching these two swimmers are going to meet, and they're going to run into each other. I would have to sit there for 3 minutes and 12 seconds, or 3.2 minutes, based on the rates that they're traveling. Now, if their rates were different, the time would be different. We have a finite distance. We have a finite time that they're traveling. We just now need to know how long does it take. A finite rate that they're traveling. Now we'll figure out the time. So, and we figured out to be 3.2 minutes. Okay, now, at the point in which they meet, how far will each swimmer have gone? Well, that's quite simple, because all we need to do is say 70 times x, which is 3.2, is one of the swimmers, and the other one is 80 times x, which is 3.2 minutes. And if we multiply each of these, we're able to determine how far each had gone. In this case, it would have been 224 meters. Okay, when you do your math. And this one would have been 256 meters. Okay? And so that's the actual distance here. 224 meters. And this was 256 meters. And if you add these two, you'll realize that they equal 480, right? Add them together, and it's 480. So that would have been just our check point, so to speak. So we've been able to answer all these questions. It's just a process that you have to take your time and you need to look at each individual bit of information, how they relate to one another. Create your equations, create your illustrations. Actually, create your illustrations first and then start building the bits of information. But remember, it keeps pointing back to distance is equal to rate times time. See, there's a foundation by which we're creating these equations here. It's distance is equal to rate times time. If we didn't have that, then we wouldn't have relationships. We wouldn't know, well, oh, they're moving at 80 meters per minute and there's a time here. This is sort of the glue that makes all of this work. It brings all of these numbers together to work. If you don't have distance is equal to rate times time, then there's no relationship to one another, and at that point you're just kind of lost. It's just a bunch of numbers that have really no relationship to one another. So again, the relationship of one to another allows you to create the equations, and again, building the smaller equations leading up to the bigger equation.